Hello friends, in this video we will see pointers. So pointers are very powerful topic or very important topic in C programming and is also most misunderstood topic of C programming. So many people find it difficult to understand pointers. So we'll try to make it simpler. In this video I'll just tell you what is pointer. I'm not going to tell you the use of pointers here. We are going to see what's the exact use of pointers in the next video. So in this video we'll just see what is pointer. So whenever we declare a variable, here I'm declaring a variable x of type int and I am assigning a value to it. So whenever I declare a variable, the compiler assigns a memory location, it occupies a memory location and names it as x. So to access that memory location, the compiler uses x. So we can also use x to access the memory location. And there will be an address for each location. So this address will not be used by us usually, but compiler will use. But we can make use of these addresses. So in pointers, the address is very important. So the address is used to point to a location. We'll see how it exactly does the work. And the value 10, whatever the value gave, the value will be saved in that location, in the location 3, 4, 6, 7, 7. This number can be different. When you compile a program, the compiler can assign 3, 4, 6, 7, 7 at once. When you compile the program again and run it, when you run on the second time, it can assign any different memory location. It's not guaranteed that it will be the same memory location every time. So this is the value, this is the address, and there's also a name for it given, which we declare here. So we can use either x, or we can also using a pointer we can access this memory location. We'll see how that is possible. So first we'll see what is address, how to get address. So that is when we declare a variable int I and we give a value 13, we assign a value 13, and we also declaring a variable of type float, that is m, and we are assigning value 56.786. So now if I say printf value of I is, so value of I is %d. So when I say %d here, so integer should be print. So that integer is I. So this is a normal sentence which we already seen the printf statement. So value of I is %d. So it prints the value of I in this location. Printf address of I is %d. So whenever we say ampersand I, the meaning of ampersand I is address of I. So it prints the address of I here. And value of m, it prints the %f. So it prints the value of m, that is 56.786 in this location. In the place of %f, 56.786 will be printed. And when we say address of m is %, you can see m is a float, but still the address will never be a float. It will always be an integer. So address will always be an integer. So we are printing it as %d. So ampersand m, that is the address of m, will be printed in the location %d. So it says address of m is the actual address number. So we have one more function called size of. So this function will give you the size of different types of variable. So in this we have considered int, long, short, float, double and char. So we have a variable I and we have assigned a value 8, L and we have assigned a value 87345, and short S 675. So these are the values we have assigned it for everything, float, double and char. So we'll see in this program we can print, in any program we can print like this, declaring the variables. Size of I is %d. And you can use percentage function, size of function here. Size of I, so it will tell you what is the size of I. size of L. It says it prints everything, size of L, size of S, size of F, everything here. So we can also print without declaring any variable. Without declaring any variable, we can print the size of int, long, short, float, double, and cap. So we'll see this program how it works. So pointers. So what are pointers? Pointers are variables like normal int. We have int m, and I've declared one more variable, int star asterisk. The asterisk symbol or the star symbol, m underscore pointer. The asterisk m underscore pointer is a variable. You can give any name. You can give star a, star b, star m, star x, star z, whatever you can give. So this is a pointer variable. So m is a normal int variable, and m pointer is an int pointer variable. But declaring will not make m pointer to point m. So currently, even though we have declared m pointer, it will not point to the m. So what we have to do to make this m pointer to point this m is, we have to assign the address of m to the mp underscore ptr value variable. If we say m underscore ptr is equal to ampersand m, the m underscore ptr now contains address of m. So if we print m underscore ptr, it will print the address of m, because we have saved the address of m in m underscore mptr. But if we print star mptr, so this is a pointer. So whenever we say star, this is also called as indirection operator, the star asterisk symbol, star m pointer, it will print the value of m because it is pointing to the m. So whenever we provide address to the m pointer, this m pointer, when we say star, it points directly to the m, a variable m location, and we can access m location using this pointer. So if we say asterisk m underscore pointer is equal to 5, the meaning is go to the m underscore ptr variable. So go to the m underscore ptr variable, get the address from it, and whatever the address you find in the m underscore ptr, go to that address and save 5 in it. So first it goes to mptr and checks what's inside it. Its inside is 34677. So then it goes to this address 34677. This is address of m. So it goes to this location and stores 5 in it. So this way m pointer directs, indicates it, the indirection operator is pointing to the m location. The m location is 34677. So whenever we say star m pointer, it goes to here. Either you can call it as m pointer or m, because both are same location. So this way we can assign values. So next, if we try to print a value from a pointer, you can see this star m pointer. So %d. So the meaning is go to m pointer, get the address from m pointer, and go to that and print the value in that address. For example, first it goes to m pointer and gets the address 34677. So then it goes to the 34677, that is this location, the m location, and value in that address will be printed here. So 5 will be printed. So this way we can use indirection operator asterisk or the pointers to access the same memory location. We can use either m or star m pointer, because m pointer contains the address of this, and star m pointer will point to the m's address. So we can use either this or this to print the value. So it is illegal to give a pointer like this. For example, we have a variable p and a pointer m and of type int, and we have a variable x and pointer n. We can provide only the address of, we cannot provide like this, m is equal to the m, we cannot give the address of a float variable because m is of type int and we cannot give address of float variable x. Again here we cannot give, n is of type float and we cannot give address of int variable. This is illegal, this is wrong, you should not give this. So what is legal, what is correct is, so this is correct, actually it should be legal here. So this is legal. You can give m is equal to ampersand p is correct and n is equal to ampersand x is also correct. Because we are appointing, we are providing the address of int variable to the int pointer and address of float variable to the float pointer. This is absolutely correct. So we'll see some programs in this video. So this is a simple program which makes use of pointer to store the value and print the value. So here you can see we have declared a variable int m and we have declared a pointer variable m pointer. You can also say give it a different name, it doesn't matter if it should be m pointer or n pointer. For example, I'll give the name as just pointer. Okay. So I'll say Alt F9. So it compiles the program. So you can see I have assigned the address of m to the pointer variable and the pointer is now pointing to m. So if we assign a value to this and print value of m, you can see it will be 55. See, I'll give a value here is equal to 99. So, but after this operation, the value of m will be 55. Even though it's 99 we have given and we are not using m again, we are using a pointer to access that variable same address. So we are assigning 55 to the pointer, so it will be definitely assigned to m because the pointer is the star PTR is pointing to the m location. So we'll do Alt F9 to compile the program and Control F9 to run. So you can see it's printing m as 55. So even though we assigned 99 here, after this assignment, so now by this we can confirm that star PTR is pointing to the m variable. Because we are printing m here, we have assigned a value 55 to a star pointer, but the star PTR is pointing to the m variable because we have assigned an address here to the PTR. So this way we can confirm that pointers can be used to access any memory location of any variable. So we'll do one more thing. We'll print address of m whenever we print, we have to use %d because those are integral numbers, comma ampersand m. So it's printing value, so it's not visible properly, so we'll do a /n here. It's not clearly separating the numbers. We'll do Alt F9, Control F9. Okay, the address is 8676. So if I assign 8676 here, you can see 8676, the address of 8676. We'll delete this right now, or I'll comment this. I do Alt F9. So non-portable pointer conversion in the function. So it gives some error. It's a warning, no problem. Control F9. So there's some exception. So you cannot give directly an address to it. because the representation of the address internally is different, because whenever we print long here, it gives a different number. You can see. Ampersand, yep. Okay, you need to print LD. So you can see it gives a very big numbers. LD, whenever you say long int. So when we want to print a long value, we can print. So you can see this time the address is different. So the address representation of a compiler will be a different. So it's very difficult for you to directly give the address. So we use always ampersand yum. So the best way of accessing a variable is provide the address like this, ampersand yum, and then this will contain the address of yum, and star pointer will point to the location yum, and whatever value you assign to it will be given to yum. So then whenever you use yum, you will get 55, or you use this keyword, this also gives you 55 because both are same location. So we'll see one more program. So in this program, we are seeing what is the size of each data type. You don't have to declare any variable to check the size of each data type. All you have to say is write a printf statement. On each printf statement, you have to say size of int, size of long, size of double, everything. We see. I'll do Alt F9 to compile and Control F9 to run program. You can see size of int is 2, size of long is 4, size of short is 2, size of float is 4, size of double is 8, and size of char is 1. You can see this is the this is because of the compiler. It's a 16-bit compiler, will assign different sizes for each data variable. Again, if you use a 32-bit compiler, so it will give you int of size 4 byte, float of size 8 byte. So it again depends upon the compiler version, 16-bit version or a 32-bit version. So this is a 16-bit compiler, so it shows int as 2 bytes of memory, long of 4 bytes of memory, short of 2 bytes of memory. So 1 byte is 8 bits, 2 byte is 16 bits, the integer is 16 bits, long is 32 bit. So we can see the size of each variable, each data. We can also check using a variable. I have created a variable here, int I, L, S, F, E, D, E. So we can print like this, size of I, size of L. So it will print like this. We'll do Alt F9. So there are some warnings because we have never used values. No problem. We'll not look into the warnings right now. We'll do Control F9. So you can see it prints size of I is 2, size of L is 4, size of S is 2. So it prints the same values whatever we saw in the previous program, but here we are using variables to check the size. So how much memory location is allocated for int 2 bytes, long 4 bytes. So this is how we can check the size of operator. So in this program we are checking the address of each variable. So I as a name, I as a value, but it also has an address ampersand I. We'll see each address what happens. Alt F9. So there's a warning here. Don't worry about the warning, which is because of the value here. We'll do Control F9. So it prints the address of all the variables. You can see the first I is at the location 9342, and the next long is at 9338. You can see the difference here. It starts from 38, 39, 40, 41. Long is 4 bytes. So it's a byte addressable memory. So every byte is given one address. So we'll start from here. So it goes in a reverse way. When a character is 9323, so it's 1 byte. So 9323 will have the entire character variable C. Next 9324 is double variables. Double is of size 8. So you can see 9324 to 9331, it is occupied. The memory location is occupied. 9324 to 9331, 8 bytes. And again float, you can see 9332 is the starting address of the data, that the F variable, and it ends with 9335. So then 9336 is the starting address of 9336 is short, and the ending address is 9337 because it's 2 bytes. 9336 and 9337 are 2 bytes occupied by short. And again 9338 is the starting address of long L. So 9339, 9340, 9341, 9338, 39, 4041, 4 bytes are occupied by long. And again 9342 and 9345, sorry, 9342 and 9343 will be occupied by I. So this will give only the starting address of each variable. Actually the memory is allocated like this. So if it has 3 bytes, if for example integer is 2 byte, so the first 2 bytes has 2 addresses, but the first address is considered as address of integer. So whenever we start declaring variables, it's stored in a reverse order. So you can see the first one has the highest number and the last one has the lowest number. So 93323, character size is 1. So 23 is the only location where the character is residing. Next, double is 8 bytes. So 24 to 31 is the 8 bytes occupied by double. Again 9332, float is 4 bytes. So 32 to 35, 32, 33, 34 or 35. So these are the locations occupied by one variable float F. Again 36 and 37, 2 bytes are occupied by S. Again 38, 39, 40, 41 is occupied by long L because it takes 4 bytes. Again in integer 42 and 43 will be occupied. So this way the variable occupies memory locations. So you should do practice, you should do a little R&D, you can call it as an R&D, how the data is, how the memory is allocated for each variable. So then you will be familiar with what exactly in the memory, how it stores everything. Friends, in this video we have learned a few things about pointers. So we have not seen the actual use of pointers in this video. We'll see in the next video when we see pointers and functions together. Thank you for watching this video.